All right, class, welcome. In our session today, we're going to do something incredibly important. We're going to bridge that gap between abstract mathematical theory and real-world practical business application. We're going to see how the math on the page literally turns into strategy and cash flow for a company.
So let's start with the central question, one that every single company, whether it's your local coffee shop or a massive global tech firm, has to grapple with. How much should we charge for our product? Now, it might seem like it's just guesswork or intuition, but what we're going to demonstrate today is that mathematics holds the key to finding that perfect price.
Okay, here's our roadmap for today. We'll start with the foundational idea, the core concept. Then we'll look at the models we use. Then we'll get our hands dirty with the calculation, see how that applies to real-world strategy, and finally, we'll cover the key takeaways you need to master this. All right, let's dive right in. What are we actually talking about when we use this word equilibrium? You're going to hear this term a lot, not just in this class, but throughout your business careers. It is the absolute bedrock of this entire analysis. I want you to picture a perfectly balanced scale, okay? On one side of that scale, you have supply. That's the number of units a company is willing and able to produce at a certain price. On the other side, you have demand. That's the number of units that customers are willing to buy at that exact same price. Equilibrium, well, that's the magic moment. It's that theoretical sweet spot where the scale is perfectly level. Supply perfectly meets demand. And for any business, this is the holy grail. Think about it. If you have a surplus, if you produce too much, that means you have capital tied up in unsold inventory, you have storage costs, waste. It's a huge drain on resources. But if you have a shortage, you've produced too little, that means you've missed out on potential sales. And you have unhappy customers who might just go to your competitor next time. So the goal is always maximum efficiency, selling every single unit you produce. So how do we take these powerful economic forces of supply and demand and translate them to something we can actually work with? Well, we use the language of mathematics. Specifically, we use functions to model the relationship between price and quantity.
Now look at these. I know they look like just a couple of equations from an algebra textbook, but they are so much more than that. These are models of real-world human and corporate behavior. Let's break them down. The supply function on the left, xs, shows that as the price, p, goes up, the quantity supplied increases, and it does so at an accelerating rate. The demand function on the right is a little more complex, isn't it? It's illustrating how demand, xd, shifts as that same price p changes.
Now, this is a really key point for all of you as future business leaders. You might be looking at that p-squared term and asking, why is it quadratic? Why not just a simple straight line? And that is a fantastic question. The answer is because the real world is rarely a straight line. A quadratic supply curve might model a situation where, to double your production, you have to open a whole new factory, causing your costs to shoot up exponentially. A quadratic demand curve can model things like brand loyalty, where your demand stays really strong up to a certain price point, and then boom, it collapses once you cross a psychological threshold. So don't just see p-squared. I want you to see the complex business reality that it represents. Okay, now for the mechanics. We have our models that represent the market. Let's find out exactly where they intersect. This is where your algebra skills stop being academic and start becoming a critical business tool. So our first step is simply to apply the definition of equilibrium that we just talked about. Quantity supplied must equal quantity demanded. Mathematically, that means we take our supply function and we set it equal to our demand function. And there it is. This single equation now represents our entire market system. All the complexities of supply and demand are boiled down into this one algebraic statement. Our job as business analysts is to solve for the one variable that makes both sides of this equation true, the equilibrium price, P.
Now, before we can solve it, we need to clean it up. We need to do some algebraic housekeeping. We're going to bring all the terms over to one side of the equation to set the whole thing equal to 0. This puts it into that standard quadratic form that you all should be very familiar with. This is a crucial step, and I cannot stress this enough. A single dropped negative sign, a simple arithmetic error here, could lead you to a completely wrong and potentially disastrous business decision.
Okay, so after we subtract 0.5 p-squared from both sides and add 200 to both sides, this is what we're left with, a much cleaner quadratic equation. And to make our lives even easier, we can get rid of that decimal. Let's just multiply the entire equation by 2. That gives us p-squared minus 200p plus 10,000 equals 0. Perfect. Now we're in a great position to solve it. So how do we solve this? Well, we can solve it by factoring.
We need to find two numbers that multiply to positive 10,000 and add up to negative 200. And of course, that's negative 100 and negative 100. So the equation factors very cleanly into p minus 100 times p minus 100 equals 0, which gives us a single clear solution for our equilibrium price.
All right, let's pause here. We have a number. We've done the math, but remember, we're not just mathematicians in this class. We're training to be business leaders. So what does this number actually mean for a business? How do we take this calculation and turn it into a concrete, actionable strategy? $100. This is our equilibrium price. According to our model of the market, this is the single price point where the number of units we produce is going to perfectly match the number of units our customers want to buy. It's the theoretical point of maximum efficiency. No surplus, no shortage. It's the price that clears the market. I want you to imagine you're in a strategy meeting. You're the analyst. You can now walk in there and say, with data to back you up, okay, team, we have our number. The price is $100. Marketing department, I need you to build all of your campaigns around this price point. Production department, we need to tool up our factories to produce 4,800 units. And how do we know that? Because we plug that $100 price back into our supply function. Let's do it. 0.5 times 100 squared minus 200. Well, 100 squared is 10,000. Half of that is 5,000. 5,000 minus 200 is 4,800 units. See? This one mathematical result becomes the anchor for the entire business plan, aligning multiple departments toward a single, data-driven goal.
Okay, let's wrap this up. I want to reinforce the key principle we've discussed, and just as importantly, I want to talk about some of the common mistakes, the pitfalls I see students make year after year. Let's make sure you avoid them. This slide really illustrates the difference between just doing the math and being a true business analyst. First, simple algebraic errors. It sounds basic, but it happens all the time and can lead you way off track. Second, and this is a big one, you get so excited about finding the price that you stop. You forget to solve for the quantity, x. Without the quantity, your production team has no idea what to do. Third, you must always run a sanity check. Does my answer make business sense? If your calculation gives you a negative price, you know for a fact you've made a mistake somewhere. And finally, remember that these models are powerful, but they are simplifications of a very complex world. They're a guide, not gospel. So if anyone ever asks you why you're studying business mathematics, this is your answer. It's not just about finding X in a textbook. It's about taking the messy, complex forces of the market, translating them into a solvable problem, and then using that solution to make smarter, more data-driven, and ultimately more profitable business decisions. And I will leave you with this final thought to ponder. Our model today was static. It was a snapshot in time. But the real world is dynamic. It's constantly changing. So your next challenge as a business leader isn't just to solve the equation, but to know when the underlying assumptions have changed, and the equation itself needs to be rewritten.